You are standing in a kitchen at a family gathering, and an aunt says to her brother, loud enough for everyone to hear, that if he really loved his kids, he would just stop drinking. It sounds brutal. It also sounds like the right thing to do. A lot of people still talk about addiction that way. Survey research on public attitudes has found a large share of the public still frames addiction as a problem of willpower or character, not medicine. A 2018 Harvard poll on opioid addiction found 44% of respondents called it a lack of willpower or discipline, and about a third called it a character flaw. So the story seems simple. You chose it, you kept choosing it, and now you need to choose your way back out. But that story runs into a problem the moment you look at the brain. Across PET and MRI studies, researchers comparing people with alcohol or substance use disorder to people without it have repeatedly found measurable differences in the circuits tied to reward and self-control. Not just bad decisions, physical changes. And that changes the question. Because if a scan keeps showing the same systems altered in the same kind of condition, then you are no longer arguing only about behavior. You are asking whether medicine is looking at the same category of evidence it uses everywhere else. In 2011, the American Society of Addiction Medicine defined addiction as a primary, chronic disease of brain reward, motivation, memory, and related circuitry. So what exactly changes? Start with reward. PET studies have found reduced dopamine D2 receptor availability in people with alcohol dependence, a sign of altered dopamine signaling that can persist even into abstinence. That matters because dopamine is part of the brain's learning signal for what deserves attention and pursuit. One key hub in that system is the nucleus accumbens. Under ordinary conditions, it helps reinforce survival-relevant behavior. Food matters. Water matters. Social connection matters. But addictive drugs push on that same circuitry in a different way. The signal does not fade with repetition the way it usually does for natural rewards, so alcohol can keep winning the brain's priority contest long after it stops making sense. Then there is the human scale of that change. In 2017, researchers at Sheikh Shuttle Hospital scanned 13 people who had reported alcohol misuse for an average of 18 years, before and after treatment. It was a small pilot study, not a miracle reveal, but the pattern was clear. Reductions in brain activity in craving-related regions matched what participants said they were feeling as their cravings dropped. For people who had spent years being told this was just weakness, that kind of result points to something different. It says the struggle is happening in tissue and circuitry, not in some empty moral space. And reward is only half the story. MRI studies and meta-analyses have found reduced gray matter volume in prefrontal regions in people with alcohol use disorder, including areas like the dorsolateral prefrontal cortex and orbitofrontal cortex. Those are regions involved in weighing consequences, inhibiting impulses, and holding a long-term goal in mind while a short-term urge is screaming for attention. In other words, the system that wants the drink is altered, and the system that is supposed to say no is altered too. That link is not just visual. Studies have found reduced frontal gray matter is associated with worse performance on impulse control and inhibitory control tasks. Not destiny. Not total explanation, but a measurable relationship between less tissue in control-related regions and less control under pressure. Then the problem gets deeper. In 2001, George Koob and Michel Lemoal described addiction within a allostasis model. The plain English version is that the brain resets its own normal. After chronic alcohol exposure, reward function drops, stress signaling rises, and the old baseline does not simply snap back when the alcohol disappears. The new set point becomes a chronically shifted one. That is why just stop is often such a shallow instruction. Even after the last drink, the brain can remain in a dysregulated state that keeps relapse risk high. Withdrawal-related changes in stress systems are understood as a major driver of continued vulnerability, which means quitting is not the end of the biological story. It is the start of recovery work. And the pattern is bigger than one person's scan. Meta-analyses of twin and adoption studies estimate the heritability of alcohol use disorder at roughly 50 to 60%. So genetics explain a substantial share of risk across populations. And that range is comparable in scale to twin study heritability estimates reported for type 2 diabetes, which run roughly 31 to 72%, depending on the study. By this point, the old moral framing starts to look flimsy. Then treatment outcomes push it further. A 2000 analysis found relapse in treated drug dependence occurs at roughly 40 to 60%, a range the authors described as comparable to relapse and non-adherence rates in treated type 2 diabetes, hypertension, and asthma, not identical diseases. Comparable chronic patterns, and treatment does move the needle. Randomized trial meta-analyses show both naltrexone and acamprosate reduce relapse risk in alcohol use disorder compared with placebo. They are not cures on their own, and they are usually paired with behavioral treatment. But they are evidence that when you treat this like a medical condition, the brain responds like one. Brain imaging studies show the same category of physical, structural change in the addicted brain that an X-ray shows in a broken leg, which means alcoholism meets the same evidentiary bar doctors use to call something a disease rather than a character flaw. So healing is not one step, it is several. You remove the alcohol, you stabilize the stress and reward system while the brain is still off balance. You use medications when they fit the treatment goal. You build behavioral support around a brain that is recovering, not a person who supposedly just failed to care enough. Then you are back in that kitchen. The aunt is still talking. The family is still listening. But now you know that if you could lay the evidence on the counter beside her, she would not be looking at a simple lack of love or discipline. She would be looking at a damaged brain trying to recover. Your father still cares about you, but his brain is literally broken.